Hi, it's Dr. Harris back for the second part of our slideshows for Chapter 2 in statistics. In the previous one, we looked at how we can do summaries for a single numerical variable. In this slideshow, we're going to be focusing on analyses that involve categorical variables. First of all, just a categorical variable by itself. Then what happens if we have a pair of categorical variables? We want to break a categorical variable down by the values of another categorical variable. And then lastly, we'll circle back and look at a numerical variable that we want to break down by the values of a categorical variable. And so we'll be seeing various RStudio commands that will allow us to perform these analyses, both graphical and numerical summaries. So we'll start by looking at a single categorical variable. The first several examples we're going to look at are going to be centered around seating preferences for college students. In the last slideshow, we looked at the data set UC Davis 1. We're going to be looking at that largely here in this case as well. And the variable that we're going to be focusing on for the most part, as I said, is seating preference. And so if we go quickly to RStudio, we see that in the UC Davis data set, this variable seat with a capital S, there are responses. Students were asked to respond, do you prefer to sit in the back of a classroom, the middle of a classroom, or the front of a classroom? And we can see that it looks like just about everybody responded. Maybe a couple people did not. And so if we want to just figure out how many individuals gave each response, we're going to use the command xtabs. And the X here stands for cross in some sense, crosstabs. And so we're breaking the variable seat down by response. And so this formulation for entering the command, it looks similar to things we've seen already. We give the name of the command xtabs, the tilde, the variable name, don't forget to capitalize the S in this particular case, and then we tell what data set it comes from. And out comes the response. And notice that it doesn't give things in the order that we might necessarily expect, the order that makes sense to us, front, middle, back. It gives us things in the order back, front, middle, and that's because it's spitting the outputs out by category in alphabetical order. There are things that we could do to remedy that, but for the moment, we're just going to leave this be and just make sure that we understand, we recognize the labels here, and that the preferences for the back are being listed first. Okay, well, it turns out that raw counts aren't always that useful for comparisons, for analysis. And so often what we want to do is we want to actually convert the frequencies or the counts to percentages. And the way we would do that is we could apply a command called rowperc, row percentages. Notice the P is capitalized here. And we're essentially going to wrap that around the output of xtabs. And so here, what's going on is xtabs is being run. It's going to get the frequencies, and then we're applying rowperc to that output. And so what we see then is down here at the bottom, we get the percentage of people who prefer the back, the percentage of people who prefer the front, and the percentage of people who prefer the middle. And in this case, these are all adding up to 100%. So again, we're applying two commands in succession here. We're doing xtabs, and then we're applying rowperc to the output of xtabs. Here's another way that we're going to sometimes do these sorts of computations. We're going to do them step by step. And notice here that we've got, we're introducing a new variable called seat UC Davis. And this less than symbol followed by the dash or the subtraction symbol forms an arrow. This is a way we assign in RStudio. This is the way we're going to assign values to variables. And so what it's saying is take xtabs, apply xtabs to seat, and take the output and put it in a variable called UC Davis, seat UC Davis. And then if we just run that single command, here I'll model this for you. So if we just run this by itself in RStudio, we are not going to get any output. Just takes what we have and stores it in the variable, but it actually doesn't give us any output to the screen anyway. And so what we would do then is if we just go in and type in or copy and paste the variable name and just enter that on its own, see that we get the output. And so what we can do then is we've got something output stored now in seat UC Davis, and then we can just apply row perk directly to that variable, and we'll get the same thing that we did if we wrapped the two commands around each other. So that's a useful technique. We'll use it from time to time. I'll try to model it in future slideshows, but we want to be thinking about sometimes we just want to store things in intermediate variable names and then apply things to that variable. And so I go ahead and describe in this slide what it is that we're doing. The less than symbol followed by the subtraction sign is an arrow that points toward let's store things in this variable name. Okay, so that's a way of getting numerical values out for analyzing the difference in responses to a categorical variable. But we can do a visual or graphical method as well. And a common one for categorical variables is a bar chart. And so we've got bar chart GC. This is a function that was written by my colleague, Dr. White, as part of a package specifically for statistics at Georgetown College. And so bar chart is going to essentially run xtabs internally and then change the output into a bar chart. And so we can remind ourselves what a bar chart is. And I'm going to go ahead and run this command. Main, if you recall, gives a label, a title to our graphical output. And so we can see we get a bar chart here. The variables are labeled along the bottom, back, front, and middle in the same order that we had before. I've got this output in the slideshow as well. And what we see is our vertical axis is labeled with frequencies, and so they're the counts. So we've got just under 40 people who prefer the back, just over 40 people who prefer the front, and well over 80 people who prefer the middle. But again, just working with frequencies, often not ideal. And so what we can do is we can change the output of the bar chart and have this vertical axis be reported in terms of percents. And we just do one last little thing to it. After we gave the title to it, we put a comma and then to type equals percent in quotes. And so that will convert the output to percentages. And so we can verify that by running it in our studio. And the only difference is the scaling on the vertical axis has changed and the labeling has gone to percents. And I've got that here in the slideshow as well. And so now slightly over 20% prefer the back, a slightly greater percent prefer the front, and well over half are preferring the middle. So bar chart GC, very useful for giving graphical output for a single categorical variable. But what happens if we want to break down, in this case, we're going to look at what happens if we want to break down seating preference by gender. So is there an association between seating preference among college students at UC Davis and their gender? So we got two categorical variables here, seat preference and sex. But we need to figure out which one do we want to be the explanatory variable here. So between the two, seating preference, gender, which one is going to be explanatory? Which one has explanatory power over the other? I'll let you think about that for a minute. If you want to pause the video, think about it before you go on to the next slide. Give you a chance to do that. I'm going to take just a few more seconds. Let you think about some more. Okay, well, I hope that you've come up with the idea that sex should be the explanatory variable. And the way to think about that is we're really trying to explore, do women and men have different responses in terms of what their seating preferences are? So we want to see that the gender, we're trying to break things down, seating preference by gender. So therefore, we want to ask, are there differences in seating preference based on the gender of the respondent? So how do we handle that in our studio? So we will use X tabs, but notice that we've got something a little bit different here. And so I want to know the breakdown of seating preferences, but I'm going to actually put the variable sex first. So I got tilde, sex, and then plus seat. So this is a different construct than we've seen before. If I've got two categorical variables, I use the tilde, but then notice that we've got sex plus seat here. And I'm modeling again, storing this in a variable. We're doing it as seat by gender. So if I copy and paste this, I'll see that I've got something stored in our studio now in the variable seat by gender. And so we get a breakdown here, and we see that the way we read this is we look at the combinations, the intersection of the row heading and the column heading. This means that there are 15 females. We look at this right here, 15 females who prefer to sit in the back. We've got 15 males who prefer to sit in the front, 40 males who prefer to sit in the middle, etc. So these numbers that we get here, these counts, represent what's going on at the intersection of the variable that's headed by the given row heading and the variable that's headed by the given column heading. But again, row perk is our friend here. We probably want to analyze percentages rather than just raw frequencies. And that's because we have different numbers of females and males, and we'd like to do a better comparison. We need to actually look at the comparisons for look at the percentages for comparison. And so I won't do this right now in our studio, but if we just apply row perk to the variable seat by gender, we'll get this outcome right here. And so again, the way to read this, females, 16% of females prefer to sit in the back, about 27 2/3% prefer to sit in the front, and almost 56.5% prefer to sit in the middle. And we could do a similar statement about the breakdown for males. Okay, so that's how we're going to just use X tabs and row perk to get our breakdown. But again, notice the order in which things were given here. Our row headings and our output were those of gender, males and females. We wanted to get the same arrangement of back, front, middle displayed as we read left to right. And so that meant our seat variable gives us the column headings. And remember that we said that sex was explanatory, seat was response. And so apparently what we're doing here is we're putting the explanatory variable first and the response variable second in this case. This is different from what we did in XY plot, where we listed the response variable first. So when we're doing a breakdown of a categorical variable by another categorical variable in things like X tabs, we're going to be giving the explanatory variable first. We would do a bar chart in a similar way. Again, we're going to list explanatory plus response here. And if I want to go straight to the percentage bar chart, I would need to include type equals %. So again, rather than take the time to enter that into RStudio, I'll just show you what the output would be. I'll let you do that yourself if you wish. And notice we've got the display is a little bit different. We've got the females grouped together and the males grouped together, which is nice. And so it's also giving us different colors for the different levels of the categorical variable seat in each grouped bar chart. So we've got the output of X tabs using row perk here, and we've got the bar chart, percentage bar chart, which gives us the same information in a graphical form. Now what we want to be able to do is say something intelligent about what we see here. We want to do some compare and contrast. And one thing that we notice, I hope, is that both groups, both males and females, prefer or have the greater response for sitting in the middle. So middle was the highest response by a fair amount for both groups. But we've got differences in overall preference between front and back between the two genders. We notice that for females, front is a higher response than back, whereas for males, we have a higher percentage preferring the back to the front. And so those are the things that we would like to try to say in a 1 or 2 sentence summary. And so that's what I've got here in the second paragraph on this slide, an example of the thing that we might want to try to say, because we want to not only be able to do, but we want to be able to interpret and analyze what we've got. And so I would say something along the lines of both genders have an overall greater preference for sitting in the middle, but females appear to favor the front more so than males, whereas males prefer to favor the back more than females. So it's just something along these lines that captures both of the things that we noticed in looking at the previous slide. We would get this from the row percentages as well. So we want to be able to not only analyze the output of row perk of X tabs, but also be able to look at the bar chart. Okay, finally, yes, before we go on to the final thing, here's an alternate way of displaying the bar chart, and that's something that our authors call a stacked bar chart, and we can get that by adding on the attribute flat equals true to our previous command. And we get something that looks kind of cool here. So our output doesn't stack the outputs of back, front, middle, side by side. It actually puts them all in a single stack. And so again, we're going back, front, middle, but we can see some of the same things that we saw previously. We see that the majority or plurality response, I think it's a slight majority in both cases, is for the middle. But we see that if given a choice between front and back, it looks like a higher percentage of males would choose the back, whereas a higher percentage of females would choose the front. So this is just a kind of a cool way to take a look at this. But I will point out, as I did in the previous slide, that the textbook gives this output in a vertical stack, whereas bar chart GC is going to give a horizontal stack. Okay, finally, let's circle back and look at a single numerical variable that we want to break down by the values of a categorical variable. And our categorical variable that we're breaking down by, again, is gender here. And we're going to go back to the NHANES 18 data set now and look at this question. Who has higher iron levels in their bloodstream, men or women? And so if we go back to NHANES 18, which you may or may not still have open, we've got two variables of interest right now: gender, which could be response male or female, as we noted before, and then iron. And iron here is given in micromoles per liter. If you look at the help file, that's what it says, micromoles per liter. And so that's what these values are here. And so we're interested in breaking down the numerical variable by gender. And so we're not going to be, because we're looking at analyzing a numerical variable, we're going to be using the commands that we saw in the previous slideshow, i.e. things like density plot, favstats, possibly in this case, we're going to look at box plots again as well. So density plot, favstats, and BW plot. And so we want to look and see what are we going to do differently now that we have this numerical variable, but we want to separate out and actually look at the analysis for all the men and then the women and do them side by side. So first, let's do the density plot. We recommend looking at the density plot first, and then that's definitely what we want to do. So density plot looks a little differently from what it does before. We've got the tilde iron, our numerical variable, but then to break it down by a categorical variable, we put a vertical bar. That's going to be the shift should be right under the delete key on the right side of your keyboard toward the top. So tilde iron, vertical bar, gender, comma, data equals NHANES 18. We give it a title, we label the x-axis, but the important part here is the layout command. And C parentheses 1, 2 essentially tells it to stack stack the two density plots on top of each other. So you'll want to be thinking about that we'll be using the multiple density plots occasionally throughout this course. And so this is one thing that you'll want to be able to do. So let's go ahead and see that this actually works. So I'll put this in here. And we see we get two density plots stacked one on top of each other. So that's present in the next slide as well. And so here's our output. I'm going to be asking you a question in just a few slides. Well, how would you describe these distributions using the language that we introduced in the previous slideshow? But here's how we get that output. And so I'm going to let you think about, how would I describe these in terms of symmetry, skew, modality, etc. Okay, so if I want to do favestats, the thing is, we don't use the vertical bar in this case. What we do is we put the numerical variable first, and then we put the tilde. And so before it was tilde numerical variable, now it's numerical variable tilde categorical variable. So numerical tilde categorical, and then we give the data set, and then it breaks things down. It gives us the 5-number summary and the mean and standard deviation for both the iron levels, for the iron levels in the blood for both the women and the men. And again, I'm going to be asking you to compare these and see what's similar about them, what's different about them, and so on. And then finally, we can do a box plot, PW plot, and it uses the same format as favestats did, numerical variable tilde categorical variable, and I could give a label, an overall title to the plot, label the x-axis, label the y-axis, and we'll see what that looks like here. And notice this time the box plots are given vertically rather than horizontally, which is what we had in a single one prior. And so again, the box plot tells us where the median is. It tells us where the first and third quartiles are. It extends the whiskers out to the lowest and highest values that aren't flagged as outliers. And so we see that there are plenty of outliers here. So here are the questions I want you to consider. We'll talk about these in class when we get together. How would you describe these distributions for the men and for the women? And how would you compare them? What's the same about them? What's different? And so we want to look at the density plot, the favestats output, and also the box and whisker plots, and just do some compare and contrast. And so we will talk about that when we get together. There is a sheet available on Canvas that summarizes what we do in all these cases. And so you want to ask yourself, how am I breaking things down? Am I breaking down a numerical variable or categorical variable? Do I have a second variable involved as well? And so, but we will get together and talk about all these sorts of things in class soon. So please let me know if you have questions. I will be back with more videos soon.